for everybody to see. So you can go to those to see it. If you want, if depending on where you're at, you can either go to YouTube to see it. That's probably the easiest way to see it. Just go to YouTube, you'll be able to see the screen. Yeah. So what's going on? May app. Nat Ruth, what's up? So this is the best way to see the screen. Just go to YouTube, and if you're already on Facebook too, you'll probably see the screen. Today we're gonna talk about some stuff that are very cool, and I really don't wanna beat around the bush. We're gonna get right into it because that's the easiest way to do it. Let me share my screen so we can get right into that. Okay, I have been getting this question a lot from some of the students, and I wanted to go over it today and kind of give you guys an overview away. Hey, what's going on, Evanson? Kind of give you guys a whole overview of it, so that way you understand it. Next time you see it in class, or if you be in homeschool, next time you see it, Terry, welcome. Next time you see it, you'll be able to to instantly grab the concept, as well as solving any problem that may come your way. So the concept that we're talking about is vectors, and also we're going to talk a little bit about matrices too. So we're going to do some operations. I'm going to show you a way where you can do operations with vectors that doesn't really necessarily require you, especially addition and subtraction, that doesn't really necessarily require you to add numbers. So you will have a visual representation of what it is to add or subtract two matrices. So that's what we're gonna go over. So and after that, I'll take some of the questions from you guys, and then we can call it a day. Oh, actually, we're gonna go over our operation with matrices too, especially matrix addition, multiplication, and I'll talk a little bit about transpose of a matrix. That's more like a definition, and maybe inverse of a matrix too. I'll talk a little bit about those, and then after that we can call it a night. Welcome, Black Magic. What's going on? Connor, welcome. All right, so let's do matrices. There you go, shall we, Connor? All right, cool. So the definition that I got for vectors is, and you guys probably noticed, it's like a quantity with a magnitude and also a direction. So when you think about the number 2 or the number 5 and number 7, 2 doesn't necessarily tell you where to go. It has a magnitude. It says this is 2. This is this is a gallon of water. This is 5 liters of milk. But when you go into vectors, not only there's a magnitude that says 5, 7, and 8, but there's also a direction. It could say 5, going this way, going that way. So that's the difference between a number and a vector. So now, what does it look like? You've probably seen them. When I say there is a direction, it points you a certain way. The vector can go this way, and normally they use bold letters for it most of the time, but I probably won't be bolding stuff the whole way. Otherwise, we're going to take you a little bit of time to finish this. So, but you can see a vector U, V, however they name it. It can go in this direction, whatever directions it goes to. So this could have, so if we have a vector U, we could say, and they denote it this way, you can have vector U of 2, 3, and that's how you would have, you know what the vector is. So now, how do we add those? So let's say I have one vector and I wanted to add to another one. So now it's common sense, when you have, if I have the number 6, and that has nothing to do with the vectors, and I wanted to add it to number 8, I know how to do that already. 6 plus 8. But in vectors, what you do is you add, the corresponding term. So you add, so if I had another vector here that's V, so what I would do, I add the 2. So if I had V of the coordinate 1, 5, for example. So what I would do, I would add the 1 to the 2, and then I would add the 5 to the 3. So they're all corresponding terms, so I would add them together. Now that's the easiest way to do that. And that's what you do in vectors. Now, I'm going to give you guys a concrete example, and we can do this as an example if we want to. So let's say we wanted to add what is u plus v. And in reality, this is probably what you're going to find in your exam. Now, before I go do this, let me give a representation of those two vectors, and I'll show you a different method to add them. You guys probably heard of this in class, or if your parents are teaching you, they probably teach you this already. It's kind of like, they call it like the tape and tail method. So to add the vectors. So let's say, and then this may not be the right representation of those. Let's say that u was going this way, and this was u. So this is the vector u, and we have it. This is the coordinate of that. This is the representation of that vector. So we have u, and let's say v was this way, going that way, the other way. Let's use purple for example. So this was v. So now let me make this shorter so you can actually see a difference when we add them. So let's say this was v right here. This was v, a little bit shorter in purple. And then u is the longer one in red. So 1 and 5. Now, this is not rocket science. This is just me plotting those. This is probably not the actual representation. I wanted to just plot those so you can understand what I'm doing. If you need to see the screen, go to YouTube. Just type the Jax tutor, and that will give you this it'll show you the screen. So now, if I wanted to add u plus v, and so what would you do if you wanted to add u plus v? So like I said, you could do operation terms. You could do the corresponding term. The 2 I added to the 3. Sorry, I erased this by accident. So I would add the 2 to the 3, and I would add the 3 to the 5, and that would give me u plus v. Now, there's another way that you can think about this in terms of representation. How do we think about those? This is what they call in class a tape and the tape to tail method. So the way it works is, you're going to take that vector u. So this is the tape of this vector, and this is the tail. I should have probably used a different color to do this. So, where the arrow is, this is the tape. If you're thinking about arrow, if you have an arrow, this is the tip of the arrow, and this is the tape of u, and this is the tail. So now what I would do is add, and I'm showing this with my pen. I don't think you can do this. So what I would do is translate this, move it all the way up, and then move it to the tape of this. So that would give me the u plus v. So what I'm going to do is, and I'll show you that so if I had u going this way, and that's the tape. So what I would do is just drag the vector v and add it to there, and then that's going to give me the length of the total vector. So what does that mean? What am I really saying? I'm saying that you can drag this, draw like something parallel to whatever v is. Where it's at now, it's at the origin, so it's not, you can't really add them, but you can drag it up all the way up to this. So it's going to be the same vector, but parallel to, the original. So the same vector parallel to the original. Now, because you keep the magnitude and the direction, you're not really changing the vector. So you're not really changing it. So that other vector that I'm drawing here is the same v, because I keep the magnitude. I didn't make it longer or shorter, and I also kept the direction. I didn't make it, I didn't change the slope of that vector. So I kept the same slope. Now, because we do this, and after you do this, you're able to add them easily. And let me see if you guys have any questions before I continue. Yeah. Hey, Ebony. What's up, Samuel? No problem, Ebony. Okay, cool. So what do we do now? We're gonna add u plus v. Okay. So let me use a different color for no reason at all. So the vector that we're going to have, the resulting vector that we're going to have, so what we're going to end up with is a vector that's going to be the sum of those. So the way you draw this, you go from the tail of the first vector to the tip of the second vector. This is u plus v. Now, let me recap so you understand really what I just did. First, I draw the vector u, and I'm not saying, not the only caveat of this is the representation in the picture is not the actual representation that I have here, because I didn't take the time to say, hey, this is what 2 and 3 would be like. But okay, now what I'm saying is you have u here and you also have v. So what I did is I draw u and then I also draw a v. Both of them, have their tail at the origin, and I wanted to add u plus v. So what I did is I left u where it was at, and then I drag v without changing the magnitude, and without changing the magnitude, I drag it all the way up to the tip of u, and that gives me u plus v. And then the vector that you see in green here is u plus v. Maybe I shouldn't have been that I should have drawn those in proportions at how they look like, but I just picked some numbers. I wanted you to really understand, where is this coming from? The u plus v, where is that coming from? How did we end up with a vector that is, that's u plus v? How did we end up with that? And what would that look like what would that look like in terms, graphically, what would that look like? But if you draw this 2, 3 in a Cartesian graph, it won't look like that. I wanted to give you a visual representation. So now, how do we do that in terms of numbers? How do we add those? And if we want to add those without, drawing the graph, how do we add those? So here's how to add those. So like I said before, you add the corresponding terms. So you add the first component of the vector. So the 2, u is of the coordinate 2, and I'll use this color to draw this. U is 2, 3, and v was 1, 5. Nope. 1, 5, right? 1, 5. V was 1, 5. So 2, 3 plus 1, 5. So what I do is I add the 2 and the 3. So what's 2 plus 3? And then u plus v would be, I add the 2 plus the 3. 2 plus 3 is, 2 plus 1 is 3, sorry. And then I add the 3 and the 5. What is 3 plus 5? 8. And that's the resulting vector that we have in green. The representation here is the only caveat here is the representation is not the actual representation of those numbers. I didn't take the time to draw it and stuff. But this is like the idea is this is how you do it. You can do it in numbers and also in terms of graphically. Now, how do we, if we can add stuff like that, there's got to be a way that we can, do subtraction. You got to take one away from the other one. So now, how do we do that? Now, the thing we need to understand in this case is, when you have a vector, if you want the opposite of that same vector, if you want a vector that's opposite to that, what you need to do is just keep the same magnitude. All you have to do is just change the direction to the opposite direction. So if it was going straight up this way, you just change it that way. That's the opposite. If it was going this way, you just change it that way. That's the opposite of this vector. So now what we do is, you see how vector v here was going from left to right this way. So all we have to do is, if we want a vector that's negative v, all we have to do is draw a vector the same magnitude, but in the going in the different direction. So it's going this way. It's going in the opposite direction of this. So this was going here, it's going this way, but it's still, at the same angle in terms of angle. So it's just going in a different direction. So wherever this was going, you just do something in the opposite direction. Now, why is that important? The reason why that's important is if I have the negative of that same vector v, if I take u and I add that to the negative of v, that means it's the same thing as saying that's just u minus v. And if you want to see the screen, I would go to YouTube. Diane, thank you. Thank you, Diane. I appreciate it. All right. So if you want to see the screen, go to YouTube and type the Jax tutor. Trust me, it will come up. So now the reason why I was saying why this is important is because you, as right now, you can add the u plus a negative v. So what I'm saying is here's what I'm saying. So if I want to find u minus v, all I have to do is find u and add that to the negative v. So now I showed you graphically how to find negative v. If v was right here going in this direction, all you have to do is just flip it, make it go the other direction, directly opposite to that. So it was going from left to right, you go from right to left. So you just change that. And I'm going to explain those in terms that you guys kind of understand, so I don't use a lot of mathematical jargon and saying that, hey, it's the opposite direction and all that stuff. I don't want to do that. So I want to make sure that you understand in terms that you normally use every day. So all you have to do is just flip this and make it go in the other direction. Now, how do we add those? Remember, it's the tip to tail. So I'm gonna need a tip of a vector, and then I'm gonna add that to a tail. Now here's what happened here, and I want to erase some of these so you can understand. Let me maybe take away this. And I want to redraw this. So you can really understand what I'm saying. Oh, no, that's not what I want to do. So I want to redraw this so you can understand. So this is the x-axis. And this was what? V, right? This was v going this way. And what I said is negative v is going to go that way, right? So negative v is going to go that way. The tip's going to be at the origin, and the tail is going to be right here. It's just the same exact thing, but just going in the opposite direction. So now what do we do? How do we add those things? And remember, it's tip to tail. So now here I have what? This is a tail, and this is a tip of vector v. So that means whatever is here, and I'm gonna go over that again so you make sure you understand. Whatever is here is u minus v. Now, let me go over that again so you understand. So when we were adding u plus v, all we had to do is drag v up all the way from here all the way up here, make that purple. So and then the resulting vector was just adding u and v. So it went from one tail to a tip. That was u plus v in green right here, as you can see in the screen. Now, tip to tail again, I have u going, which is the vector in red right here, as you can see on the screen. And I had v going this way. If I wanted negative v, all I have to do is just, change the direction from where to the exact opposite direction of where it was going. Now, I have this, the tip becomes at the origin, and I just draw a line here from the tail to the tip, just like we did here for the one in the green, from the tail here to the tip. And this one is u minus v. Now, how do we do that in terms of numbers? In terms of numbers, how do we do that? How do we do u minus v? How do we add those two vectors in terms of numbers? How do we do that? Now, here it is. So I have one vector that has a coordinate 2, 3, and one of them with 1, 5. So 2, 3, U, and I'm writing this in blue, 2, 3, and then we have V, 1, 5. So how do we do that? How do we make sure we add these two together? So what we're going to do here is add. So we're going to do the same thing again. U minus V is the same as writing U plus, because we already know how to add them, negative V. Now, negative V here is V going, so negative V here is V multiplied by a negative 1. So I have V here. All I have to do is minus V by a negative 1. And I haven't shown you how to multiply by a negative 1, but it's as common sense as it sounds. So you just multiply the negative 1 here by this one, or multiply it by this one. Now, if that doesn't, if this registers to you, eventually what you're going to start doing is saying that, okay, I just need to do 2 minus 1, 3 minus 5. Essentially, that's what we're doing here. 2 minus 1, which is 1, right? 1. And then 3 minus 5, which is negative 2. So that's what we're doing here. And that's U minus V. That is U minus V. So 2 minus 1, 1, 3 minus 5, negative 2. Cool. Yeah, that's it. That's how you do U plus V and U minus V. Now, let me see if you guys have any questions, or concerns, or anything at all. Cool. Reginald, what's up? Thank you. Reginald. All right, cool. So, another thing I wanted to show you guys is what I was saying. Another thing I wanted to show you is talk about is vectors. I think we can talk about a little bit about scalar multiplication. So let's say I have a number here, and we touched on it earlier. So let's say I have a vector here, U, and let's do 2, 3 again. And I have, so what is 3U? 3U. And it's exactly as it sounds. It is 3 multiplied by U. So what do? We multiply the 3 by the first component, and we'll also multiply that 3 by the second component. And that's all you do. So it's 3 times 2, which is 6. And you multiply the 3 by this 3, which is 9. So that's 3U. And that works for any numbers. A negative number, if you have a number like 1 over 5, you just multiply it by each one of the components. And that's all you do for this one. Now, let me see if I can do something else. Let me see if you guys have any questions. Welcome. Coden, welcome. Tokyo, welcome. Lee, welcome. Let me see if I see. Elisa, welcome. Claudia, Ashley, Alexis, Sean, welcome. Michaela, welcome. Maria, welcome. All right. You guys have any questions? Toki, you got it. What's the test about? What's the test on? What is it on? What is it a math test, or and what grade? For what grade is it, Tokyo? All right, let me see if you guys have any other questions on Facebook. Nope. Yeah. Okay, if I don't see any questions, I will. Let me see. Kate, welcome. So So this is what I wanted to show you guys, and I think we can do next time. We can do matrices like the additions and multiplications. Um, if you if you have any other questions, you can probably send them to me. Um, if you a client and you have questions, you can send them to me. Let me see. Devon, welcome. Shell Brown, welcome. Kennedy, welcome. Let me see who else is here. Cool. So, so the next time we're gonna go over the matrices. So we're gonna do some operations on them, and we're also gonna do. I'll show you guys how to find transpose, inverse of a matrix, add matrices together, and do multiplications of matrices. If you part of the course, there is algebra. If you part of the Algebra 2 course, you should be able to send me like you could use the number in there and just send me a like a screenshot of what you're working on, and then I'll be able to help you. Welcome. Okay. All right, guys. So I think this is all I wanted to show you as far as this is concerned. I don't see any other questions. So next time, so I think this is all for like vectors. We could do something else. Like actually, let's see if we can do dot product of u times v, and that will complete the vector section. And next time we're going to talk about matrices. Let's do dot product. So let's say I have u here, of coordinate of u is what is it, 2? Is that what it was? 2 and 3, and then v is what was v? V was 1 and 5, I think, right? So the dot product is, you take one u, and they use a dot actually for this, dot v. What is that equal to? So now what you do is you multiply the first two components together, plus, so it's 2 times 1, and then you add that to whatever the last 2 was, multiply it together. So 3 times 5, right? And it's not hard. It's not stuff that are like hard to follow or anything like that. So what it is you just multiply this times this, and then the other way that you can write vectors is another way that you can represent them. You can put the 2 and the 3 here. The 2, 3 times, it's the same thing as 2, 3 times 1, 5, right? So you multiply the top ones, 2 times 3, and you multiply the bottom one, 3 times 5. But if you have it written this way, you multiply the 2 times the 3, you multiply the 1 by the 5. Now, it's not I don't think one of them is necessarily easier or harder. I think you can, you can look at it as you multiply corresponding terms together. So first terms, you multiply them together, and the second ones, you multiply them together. You don't really have to know, I don't think you have to know a whole lot about that to understand it. So what is 2 times 1 is 2. 3 times 5 is 15. 2 plus 15, which is 17, correct? So that would be what this one would be equal to. 2 times 2 times 1, which is 3. 3 times 5 is 15. Now, I think this is all I need to cover. So let's recap. So the first thing that we did when we came here is, of course, I said hello. I didn't just jump into it. So the first thing that we did is when we came here, we did I told you guys what we're going to be doing. I said, hey, we're going to do operations on vectors. Let's see. Yeah, so I say that I'm going to show you guys how to do operations on vectors. So now the first thing I said, okay, what's the definition? What does Wikipedia say that vector is? So I went into the definition and told you guys, okay, it is something that has a magnitude and a direction. I compare that with a number, which is, a number has magnitude only. So it doesn't say this is 4x going to the left, going 45 degrees. It doesn't say that. It doesn't say this is 4x with x coordinate 1 and then the y coordinate 0. It doesn't really say that. They just tell you this is 4 eggs or this is 5 bananas. So now vectors are different from numbers where they have, not only they have a magnitude, but also they have a direction. Second thing that I end up doing is I show you how to add them. I show you how to add them with on a graph using the tip to tail method, but I also showed you how to add them, adding the components that look alike, the corresponding components, and then I also show you how to do one vector minus another one. I showed you how to do that. The last thing I think I showed you was the dot product. So I showed you how to multiply them. I also showed you how to do like a scalar multiplication, which is when you have a number multiplied by a vector. And it really is common sense. It's not that difficult to grasp. As long as you know how to multiply numbers, it's easy to grasp this. So, and that's it. That should do it for now. And next time we'll do the operations on matrices. And I think those are a little bit, I don't want to say difficult. Those are a little bit different. There are certain things like you see how with those vectors, you could add them multiply them easily, but matrices are a little bit different. So next time, this is what we're gonna do. Yeah. So next time, this is all we're gonna do, and I think this is it, guys. And I don't want to say this a lot again. I think this is it. So thank you all for coming out, and I appreciate you and Ebony, Samuel, Jennifer, whoever else was on here. I appreciate you guys, and let me see who else is in here. Aloha. You guys have crazy username on here. All right, cool. So that's it. That's all. So if you want to see the screen or you want to see the replay, I would say go to YouTube and type the Jax Tutor. Of course, if you're seeing this, you're not on YouTube. Okay. You're already on YouTube if you're seeing this. Okay. All right, guys. Thank you. Bye.